Good morning, stats class. You'll notice that today's notes are for 10.1 when our notes on Canvas include 9.2. Because we lost our week, 9.2 was cut from the material. So this is actually, we only have 4 sections left, 10.1, 10.2, 4.1, and 4.2. What that means is we can really go 1 section per week, but what I want to try to do is get 2 sections in this week and then do 1 the next 2. That leaves you the last week to review everything that could be on the test. And I want to be teaching right up until the end. So let's get going. 10.1 is a lot of learning and almost no math. It's really about understanding what's happening. So we start with hypothesis testing, which is a procedure used to test statements regarding a characteristic. So someone will say something like a report from maybe like 2005 says 27% of males between the age of 21 to 30 smoke. So someone will say something that would be like a null hypothesis down here, a statement that you want to test because it's been 15 years and you either think that that number is different, it could be higher, it could be lower, you're not sure. So you need a procedure to test it. So you'll have to collect evidence because this will behave a lot like a trial. When someone goes on trial, the prosecutor tries to find evidence to conclude they are guilty, or you don't find enough evidence and they don't say that they're innocent, they say that they're not guilty. So you're either going to find evidence that the hypothesis, the null hypothesis, is false, or you're not going to find evidence, which means you have to leave them, you can't say that they're false. So you'll give an alternative hypothesis. For example, I would say the number of males aged 21 to 30 is less than 27%, something like that. So there are 3 different ways this can work. 3 ways a test works. You say, okay, so if the H0 is always going to be the same, your null hypothesis. It's the statement you're testing. It's always going to be a parameter, P equals some number. Now, if you think that number is wrong, but you don't know if it's greater than or smaller than that, you're just simply going to say your hypothesis, H1, is going to be, I think the parameter is not equal to that number. This is going to be what we call a two-tailed test because it could be higher or lower. There's 2 sides that you're testing around. Number 2 is when you have more certainty. So P is always going to be equal to the number, but you're like, well, there's no way the number is that low, so you think P is strictly greater than that number. What that will do is give you all your margin on the top half of your z-score table, which we'll talk more about in 10.2 when we actually calculate that. And of course, what else can happen besides greater than? We have your hypothesis, the alternative, is less than. That gives you all your margin on the left side. So page 2 is all about writing hypotheses out given the scenario. So number 1 says, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So their initial statement, the statement they want to test, is that the original population proportion is 0.62, 62%. Now, what does different mean? The researcher thinks it's different. Did he say higher? Did he say lower? No, he only said different, which means he just wants to prove that it's not 0.62. So the words are what's going to determine whether or not it's a not equal to, a less than, or a greater than. Let's look at number 2. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes the mean length of a call has increased since then. So his initial null hypothesis is P is 3.25. What is the researcher's alternative hypothesis? that P has increased, so it's greater than 3.25. Now, why? I actually think that probably has increased, not because people talk longer, but most of the time if you're having a short conversation, you end up having it by text, and it's only like the long conversations with family that you end up being by phone most of the time. So I think that's probably true on cell phones. Number 3 says, according to the CDC, 15.2% of American adults experience migraine headaches. Stress is a major contributor to the frequency and intensity of headaches, and massage therapist feels she has a technique that can reduce the frequency and intensity. So the initial is that the population proportion is what? 15.2%, which is 0.152. She thinks that if she applies her technique, she can get that number to be less than 0.152. Now, you could argue that when it's population proportion, we should probably use p hat, but we'll talk more about that next time. We're just setting it up right now, what H naught is and what H1 is. Now, that's all that page 2 has. Page 3 is about the types of errors. Type 1 error. So a type 1 error occurs. Let's talk about outcomes. If we're talking about it from a trial perspective. A person's either guilty or they're not guilty, but they could also be innocent or guilty. For example, you could find someone guilty, but they could actually be innocent. So that creates 4 issues. Now, if you find someone guilty and they actually are guilty, you did the right thing. If you find someone not guilty and they are innocent, you did the right thing. But you make errors, right? Juries do this a lot. If you find someone guilty when they're innocent, that's an error. But if you find someone not guilty when they actually committed the crime, that's also an error. So those are the equivalent 2 types of errors. So type 1 error is when you reject the null hypothesis, but the null hypothesis was actually true. A type 2 error is instead where you don't reject the null hypothesis. You didn't find enough evidence to convict the null hypothesis. But it actually H1, the alternative hypothesis, that was true. Now, some people argue the power of these 2 things, and I would argue the same way. Type 1s are usually scarier, especially if you use the criminal trial comparison. To find someone guilty when they're actually innocent, so to put an innocent person in prison, to me is far more of an issue than to not find someone guilty when they actually did something, because most of the time if someone's going to commit a crime, they're going to do it again, so you'll catch them eventually. But to put someone innocent in prison, to me, is one of the worst things. So you can fill out the charts below this on page 2. Just remember that they're equivalent. So the type 1 errors are going to be in the top left corner, and the type 2 errors are going to be in the bottom right corner. So that's all for the first half of this video, and we'll do the second half later.